8.4. The following figure depicts two circular motions. The radius of the circle, the period of revolution, the initial position, and sense of revolution are indicated on the figure. Obtain the simple harmonic motion of the x projection of the radius vector of the rotating particle p in each case. Okay, here the radius is given by a and here the radius is given by b. Okay, so then look at that question. Okay, so these are the two figures. Now we have to express the simple harmonic motion. So first we are taking this first cycle, and according to this cycle here, we have, when we are writing the simple harmonic motion, that is displacement x is equal to a cos omega t plus pi. So there is a one we have to concentrate on that, which kind of rotation is this. Okay, whether it is a anti-clockwise direction or it is a clockwise direction. So when the sense of rotation is changes, then our equation is also changing. So here the particle is performing the anti-clockwise direction. Okay, so now we can write here the position of the particle. So here, while this particle is moving on the circumference, while it is moving on the circumference, then foot of the perpendicular of that particle, or shadow of that particle is moving to and fro about mean position along x-axis and also along y-axis. Already we have seen this in our simple harmonic motion. Okay, but here in this asked that x projection, we need to x projection means now our particle, when p is equal to p, it is the position of the particle when time t is equal to 0, it is located at here. Okay, and its x projection means it is our x projection. Okay, so this is we call here reference line in the anti-clock direction. So already before starting the motion, it is already having some angle, and that angle we call here initial phase angle or initial phase, that is pi is equal to 45 degrees, that is equal to pi by 4. It is our initial position of the particle when in anti-clock direction. Okay, then after some time, this particle is moving from this position to somewhere here like this. Okay, this is another position, and here the angle made by that is omega t. So the total angle from here to here, that is already we know that x is equal to, that is a cos omega t plus pi. Okay, or also we can write like this. So how we can write it is, for suppose um, this is our particle, it is initial position and somewhere it is here, from here to here it is moving with some omega, and here it is we have a pi, and up to here it is equal to omega t. So now the particle is at here, and from that we drawn the one perpendicular on the x-axis, because they are asking the x projection. So this is our x displacement from the mean position. Then how can we find out this x projection means, it is making some angle here, that angle is equal to omega t plus pi. So that omega t plus pi means we want to this one. Okay, here we find this kind of one triangle, this is our triangle, this is a radius of the circle, and here the angle subtended here omega t plus pi. Okay, so then this is our x-axis from the origin. Okay, now we have to find out this x projection. Okay, this distance now we want to here. Okay, so means this is nothing but, it is for theta, it is the adjacent side. So adjacent side we can see in the cos Okay, that is cos omega t plus pi. That angle is equal to adjacent side, that is x by a. From that, x is equal to a cos omega t plus pi. This is the equation. So it is, we can express this is a of cos omega, we can write here 2 pi by capital T into small t plus pi, and x is equal to a cos of 2 pi by here capital T. So in this, while this sensation, the capital T is given here, that is equal to 4 seconds. While it is moving in anti-clock direction, the capital T is given t equal to 4 seconds. So then t, I am substituted here 4 into t plus pi. So it is x is equal to a cos of 2 ones are 2 twos are. So that is pi by 2 t plus pi. This is the equation for the simple harmonic motion while in a anti-clock sensation. Okay, while particle is moving in anti-clock direction. And then second diagram, if you are observing there, the particle is moving clockwise direction. Here it is clockwise direction. Okay, in clockwise direction, we are taking that the reference line is, we are taking as air. Okay, so here in anti-clockwise direction, we are taking the x-axis is the reference line, and while it is performing the clockwise direction, this positive y-axis we are taken as the reference line. So from that, it is our mean position, like, so from here it is started. Okay, so from that angle where angles we are measured from the this reference line only in clockwise direction, but it is different in the anti-clock direction. In anti-clock direction, we are reference line we are taken on the x-axis, and the reference line taken in clockwise direction is on positive y-axis. So according to that, here the initial phase is equal to 0 because it is already on the reference line. So that's why initial phase equal to 0. Then after some time it is moving here with some angular velocity omega, and it is subtending some angle here, and that is equal to omega t in small t time. Okay, so because here when it is initially p, our particle is at reference line. Okay, then it is moving in the anti-clock direction. Okay, with omega. So after some time, if the particle is at here, it is subtending an angle omega t. Then again here is also we have to write the x projection. This is our x projection, means the shadow of the particle on the x-axis. This is our x. Then now we have to find out this x, how much is this x, but we know that, so whatever the angle here, and this angle is also same, that is equal to omega t. Then for that it is opposite side, so that's why we can write here sine theta. So sine, what is the theta here, omega t, and that is equal to x by, here the radius is given by b, so that is equal to b. Okay, so radius means whatever the ear radius, and this is also how much, that is also b. Okay, so from that x is equal to, this is b sine omega t. Okay, so this is x is equal to b sine omega t. Okay, so pi is equal to 0, there is no need to write it. Okay, then x is equal to b of b sine of omega, we can write here 2 pi by capital T into t, and this is x is equal to b sine, that is 2 pi by capital T. In this case, in this clockwise direction, uh, time period is given by um, 30 seconds, means after every 30 seconds it is repeated its motion. So then t into small t, sorry, t is equal to here 30, then 2 ones are 2 15s are. So x is equal to b sine of This is pi by 15 into t. This is the x projection or simple harmonic motion equation in clockwise direction. And this is also we can express like this, that is x is equal to, this is b cos pi by 2 minus pi by 15 into t. Okay, that that is also we can express like that, because uh, cos 90 minus theta, that is equal to sin theta. Cos 90 minus theta is equal to what? Sin theta. So this is also expressing like this and also like this. Both are correct in this situation. Okay, so this is about mm, and also we can express this is like this, what x is equal to b of, if you are taking uh, minus is common in this bracket, that is minus of, this is pi by 15 into t minus pi by 2. Okay, means if you are multiplying into the bracket, then we are getting the same this one, that is minus pi by 15 into t minus into minus plus pi by 15 into t. So this is x is equal to b cos of minus theta, that is equal to cos theta. So then this is pi by 15 into t minus pi by 2. Okay, this is also correct. Okay, so you can write this one or this one or this one, all are the same. Okay, this is the simple harmonic motion in clockwise direction.